Hello my dear students, once again welcome back to our channel. I am your maths teacher CG ma'am. In this video, we are going to discuss about the division algorithm for the polynomials. This is the last topic of this lesson. Okay, the division rule we know. That is, what is the division rule? That is, dividend is equal to the divisor into quotient plus the remainder. Okay, the same division algorithm is applicable for the polynomials also. That means if you are dividing a polynomial, okay, the polynomial to be divided, let it be p of x with g of x, that is divisor polynomial is g of x. As a result, we will get the quotient polynomial and the remainder. Okay, so according to that division rule, that is p of x is equal to, that is g of x into q of x plus r of x. That is the division algorithm for the polynomials. Is it clear, children? P of x is equal to g of x into r of x plus g of x into q of x plus r of x. Okay, here there is very important condition. That is, this r of x, that is remainder polynomial, can be 0. When we are getting remainder 0, if g of x, both g of x and q of x are the factors or divisible by the p of x. I will give a numerical example. See, suppose if can we write this 18 as 9 into 2. In that case, remainder is 0. Okay, that means here 9 divides this 18. In that case, remainder will be 0. Okay, you can divide 18 with 2. Okay, in that case, remainder equal to 0. That means both 9 and 2 are the factors of 18. Understood? In another way, if I am giving another example, let it be 25. Okay, I am going to divide this 25 with 3. Okay, that means here g, that is the divisor is g is divisor is, let it be 3 and quotient will be 8. So in order to satisfy this division rule, we should have definitely a remainder and let it be, and that can be 1. Okay, in this case, this remainder is always less than the divisor 3. The same result we can apply here in terms of degree. That means the degree of r of x is always or strictly less than the g of x. So you have to continue the division process till you get the remainder 0 or the degree of r of x less than degree of g of x. This is all about that is division algorithm. Okay, from this very important relation, you can also calculate, sometimes in some of questions we may given that p of x and q of x, also the r of x. We have to find out g of x. Okay, if g of x or q of x, quotient polynomial, is asked, when p of x and r of x are given, you can derive one very simple relation from this. That means in order to get g of x, what can be done, children? This r of x can be taken to this side. So p of x minus r of x. If we need g of x, this q of x will be the denominator. If we want q of x, okay, this g of x will come to the denominator and there is no change for the numerator. That means we have to take this r of x along with the p of x. So p of x minus r of x divided by q of x. That point is clear. These are the very important points to be applied in the next exercise. So let us start the exercise work. So we are going to solve the problems from exercise 2.3, question number 1. See, children, here we have to divide this p of x, that is x cube minus big polynomial, cubic polynomial, with the g of x, and we have to find out quotient and the remainder. Okay, so children, how we can proceed? We can apply the long division method to get the q of x and r of x. Okay, so I am keeping this divisor, that is x square minus 2x. Okay, so before you start division, children, see that the given p of x as well as the g of x are in the standard form. Okay, that means cubic polynomial means it will have 4 terms. Okay, 3 plus 1 terms. Okay, so x cube term, x square term, x term and constant, 4 terms are here. Okay, so this is in the general form, standard form of a cubic polynomial. The p of x is in a general form. Okay, then let us see what about g of x. It's a quadratic polynomial, so it must have 3 terms. 2 is the degree, so 2 plus 1 terms, that is x square term. Next comes the constant. Okay, you can divide this p of x with its original form, that is x square minus 2, but it may leads to some error. So to avoid that unnecessary mistakes, it would be always write this given g of x in the standard form of a quadratic polynomial. What I meant is here the middle term, that is x term, is missed. So we can write that term by making its coefficient 0. Okay, so that is the way I am going to solve this problem, divide this problem, that is x cube minus 3x square plus 5x minus 3 can be divided with its g of x. Okay, g of x, that is x square, okay, plus 0x minus 2. This would be better. Okay, and how that division can be started. See children, in the p of x, which is the first term, that is the first term in p of x is x cube, right? Divide the first term of the p of x with the first term in g of x, that is x square. That point is clear. In order to get the first term in the quotient q of x, divide this x cube with the first term of the g of x. Okay, that is x cube minus x square. Okay, that means x. By loss of exponents, that is a raised to m divided by a raised to n is a raised to m minus n. So 3 minus 2, or x into x into x divided by x into x. So 1 x will be there in the numerator. This is that x. So x cube by x square is x itself. Okay, so we can write that as the first term in the quotient polynomial. Okay, how that x is, we got the first term x is clear children? Okay. Now, with that x, you multiply each term in g of x. Okay, so x into x square, x cube. Okay, and write those terms according to their places. Okay, that is regarding their power, degree. Okay, then x into 0x square, okay, plus 0x square. So x cube term should come under x cube term, x square term below this x square term of the p of x. Okay, and we have one more term, that is minus 2. So x into minus 2 minus 2x. You multiply along with its sign. Okay, so minus 2 into x, that is minus 2x minus 2x. Okay. I hope this step is clear. Just get to that first term in the quotient by dividing this first term with the first term in the g of x. So we got x here. So multiply each term in the p of g of x with the x. Okay, so we will have this polynomial. Okay, now the next step is very, very important. Okay, that means we have to change the sign of the new polynomial obtained. Okay, that is here plus x cube become minus x cube. Okay, and 0 plus sign minus. Okay, and minus 2x become plus 2x. Change the sign, then add. Okay, because we know like terms can be only can add or subtract. Okay, that is why we have to write this according to the degree. So x cube and minus x cube get cancelled. Okay, and minus 3x square minus 0x square is minus 3x square itself. So minus 3x square. Okay, now the x term plus 5x plus 2x. after changing this sign of minus 2x, now we have plus 2x. So plus 5x plus 2x become, add the coefficients, 5 plus 2 7, then x. Okay, no change for the variable, and this last term minus 3. This step is clear, children. After getting this polynomial, change the sign, then add. We are adding. Okay. So now we have a new expression, new polynomial. Okay. So we have to continue, because here the degree of the polynomial is 2. Here the degree of the g of x is 2. What is the condition? Degree must be always less than degree of g of x. R of this is remainder. Okay, after divide we got this. That means this is not the actual remainder. We should continue the process till you get either the remainder polynomial as 0 or its degree less than this. That is the condition. Okay, so in order to continue that one, you consider the first term of this new expression, minus 3x square. Divide this minus 3x square with always the first term in the g of x, that is x square. Okay, now what happens, children? X square get cancelled. So the coefficient of x square, that is minus 3, is alone there. So minus 3 is the second term in q of x. Okay, now we can multiply each term of this g of x with the minus 3, this polynomial. Okay, so minus 3 into x square minus 3x square. Okay, consider the sign when you are multiplying. Okay, and minus 3 into 0, that is 0 or minus 0. Okay, there is no difference when you are adding or subtracting any number with the 0. Okay, so minus 0x. Okay, and minus 3 into minus 2 is plus 6. This step is okay, children. Now, as how we change the sign, the same way we have to change the sign of this polynomial. That is, this plus 3x square become minus 3x square become plus 3x square. Okay, now this also plus, and plus 6 become minus 6. Okay, now we can add, that is minus 3x square plus 3x square. After changing minus into plus, both get cancelled. Okay, here plus 7x and 0x, that is 7x itself, plus 7x. Okay, and here constant minus 3 plus minus 3 minus 6 is minus 9. This step is okay, children. Okay, so here the degree. Okay, here we can't take any number to down. We can bring all the terms we already considered. Okay, now 7x. Here the degree of the remainder polynomial, and see the degree of the divisor polynomial. So less than. So this we can stop the division. That means this is the remainder. This is r of x. This is very important. You should continue the process till you get the remainder 0 or the degree of r of x less than degree of g of x. Okay, so q of x is equal to x minus 3 and r of x is equal to 7x minus 9. This is all about the first question. Okay, now we can solve the second problem. Now we are solving the second problem, that is we have to divide this p of x with the g of x. Okay, see children, so what I said, before you start the division, you see that both the polynomials are in its standard form. Okay, see in the fourth degree polynomial, okay, see x raised to 4, next comes the term with the power square. That means the x cube term is missing here. So we have to make that term by writing the coefficient of that term 0, and x square term, then constant term. And in g of x square, next comes the constant. So a rearrangement is needed in this case. Okay, so after, what is the general form of a quadratic polynomial? Ax square, next x term, then only constant. Here all the three terms are here. Okay, but just a rearrangement is only needed. So x square minus 6 plus 1. After making that correction change, you can start the division process. Okay, that is what I am going to do. That is p of x. Here we need x cube term. Okay, so x raised to 4 plus 0 x cube minus 3x square. And here g of x is x square minus 6 plus 1. We are going to divide. Okay. So what is the process, children? In order to get the first term in the quotient, consider the first term, that is x raised to 4 divided by the first term in the divisor polynomial g of x, that is x square. Okay, so x raised to 4 divided by x square is 4 minus 2. Okay, that is x square term. Okay, this x square and x raised to 4 now becomes, after cancelling x square, that will be the first term in the q of x. Okay, so multiply this polynomial, each term of g of x with the first term of the quotient, that is x square. So x square into x square, x raised to 4, okay, x square minus x cube, should write under the x cube term of p of x. Okay, now x square into 1 plus x square. These are the 3 terms, because we have 3 terms in the g of x. So multiply with x square. Now what is the next step? Change the sign and add. Okay, that means we are going to change the sign. So minus, this minus become plus, this plus become minus. So x raised to 4 and minus x raised to 4. Okay, same variable, same power, different sign can be cancelled. Okay, here 0x cube plus, now after changing the sign, now the new sign is plus x cube. So x cube. Okay, and this plus become minus. So minus 1, minus 3, minus 4x square. Okay, x square term should come under the x square term of p of x. So minus 3 minus 1, minus x square means its coefficient is minus 1. Okay, now we can bring down this plus 4x plus 5. Okay, so we have to continue the division, because here the power is 3, here the power is 2. Degree of r of x definitely less than this one, or 0. The whole remainder must be 0. Then only we can stop the division. Okay, so we can continue by considering the first term x cube, divide x cube with, always divide with the first term of the g of x, x square. So x cube and x square, x is remaining. So plus, okay, here is plus, here also plus, so plus x. Okay, multiply this whole p of g of x with x into x square, that is x cube, x into minus x square, x into plus 1 plus x. Okay, and next is change the sign. Okay, that is minus x cube plus x square minus x. Okay, now we can cancel x cube and minus x cube. Okay, minus 4x square plus x square. Plus x square means its coefficient is 1. So we can add or subtract the coefficient. So minus 4 plus 1, minus 3 and x square. Now the next term, x term, that is 4x and minus 1. Minus x means its coefficient is minus 1. So plus 3x, and the last term, that is the constant term. We have to continue because square term, here also square term. So in order to get the next term in q of x, consider the first term minus 3x square divided by, always with the first term in g of x. So x square term get cancelled. Children, here we have to consider the negative sign. Don't simply divide 3x square with x square. Okay, minus 3x square. So we have minus 3 comes. Okay, So minus 3 into x square minus 3x square minus 3 into minus x plus 3x minus into minus plus minus 3 into plus 1 minus 3. Next is changing the sign, minus become plus, plus become minus, here also become plus, minus become plus. Okay, so minus 3x square plus 3x square get cancelled, and also here 3x and minus 3x get cancelled, but the remainder, the constant is remaining, plus 5 plus 3 plus 8. Now here the remainder, constant polynomial, so its degree is 0, so less than this one, so this is the final answer. So g of x, that is this one, q of x is equal to x square plus x minus 3 and r of x is equal to 8. This is the long division of the second problem. Okay. Now we can solve the third question. Okay. Here the p of x, okay, is x raised to 4 minus 5x and 6. Okay, this is a fourth degree and x cube term is not there, so I made by making its coefficient 0, and x square term also missing, so plus 0 x square, then minus 5x and plus 6 is there. Idea is clear, children? It should be, the degree should arrange in descending order to avoid unnecessary mistakes. Okay, this is not that much compulsory, but it would be better to avoid mistakes. Okay, and at the same time in g of x also it is given 2 minus x square. Okay, it's a quadratic polynomial, so x square term, then x term, then constant. Okay, so I have written minus x square, I rearranged, then plus x term 0x plus 2. Idea is clear, children? So we can continue as usual by considering the first term of the p of x, that is x raised to 4. Divide x raised to 4 with the minus x square. Minus x square. So x square and x raised to 4. So x square. So minus is there. So minus x square. Then multiply each term with the new term in the quotient, that is minus x square into minus x square plus x raised to, always consider the sign. Okay, and minus x square into 0, that is minus 0x cube. Okay, and minus x square into plus 2 minus 2x square. Okay, keep the terms below its power. Okay, that would be better. Now change the sign. So minus plus minus plus. So x raised to 4 minus x raised to 4 get cancelled, and this term also get cancelled, 0 0. Okay, nothing will happen, and here 0x square and plus 2x square. So 2x square plus 2x square and minus 5x plus 6. Understood? So we have to continue because x square term, x square term. Okay, so in order to get the next term, consider the first term 2x square divided by minus x square. So x square get cancelled. 2 by minus 1, minus sign means minus 1. Okay, so minus 2. Okay, the standard form of a rational number, the minus sign will go to the numerator. So minus 2. So with minus 2 you have to multiply each term. Okay, that means minus 2 into minus x square plus 2x square minus 2 into plus 0x minus 0x minus 2 into plus 2 minus 4. Okay, again change the sign. Okay, plus and plus. Okay, so plus 2x square minus 2x square get cancelled. Minus 5x plus 0x means minus 5x and plus 10. 6 plus 4, minus 4 become plus 4 after changing the sign. So constant now is 10. So minus 5x plus 10 is the remainder because we have now an expression whose degree is less than this g of x. That means we can't divide further. Okay, that is very important. Degree can be remainder polynomial can be 0, or the degree is less than the g of x. That means this is the r of x, remainder polynomial, and this is the q of x. So q of x is equal to minus x square minus 2, and r of x is equal to minus 5x plus 10. Is it okay, children? Now we can solve the next problem. Now we are solving second problem, second question. Okay, in this problem we have to check whether the g of x, okay, is a factor of p of x. Okay, this is about the polynomial. How can we check whether the given polynomial is a factor of p of x? See children, if we have numerical example, that is if when we can say that 2 is a factor of 18, that means if you divide 18 with 2, okay, you will be getting 9 as the quotient and the remainder is 0. The same idea we are applying here. Okay, if you divide the given, that is p of x, with the g of x, if we can show that the remainder is 0, the given g of x is a factor of p of x. Understood, children? Okay, so let us start division. Okay, so we can divide this p of x with the g of x. What is g of x, children? X square plus 3x plus 1. Okay. See children, the given p of x is a 4th degree polynomial. So it must have 4 plus 1 terms, 5 terms. See, 4th power and 3rd degree and second power, x square is there, and the x term is there, and a constant term is there. Okay, so this is in the standard form, and also at the same time g of x also in the standard form. It has 3 terms, its the degree is 2. Okay, so we can start division by considering the first term in the p of x, that is 3x raised to 4 divided by x square. Always we are dividing this p of x, okay, that first term with this first term in the g of x, that there is no change for the denominator. Okay, that is x square should come in the first term divided by x square. Okay, so x raised to 4 and x square and x raised to 4 2 times, x into x into x into x. So from the 4 x's 2 x's are cancelled, so remaining, so the power of variable is 2. So 3x square is the first term, and after getting the first term we can multiply all the terms in the g of x with the 3x square. Okay, so 3x square into x square. What is the multiplication law of monomials? Multiply the coefficients and variable separate. We can multiply the coefficients. 3 into 1, 3. The coefficient of x square is 1. X square into x square, x raised to 4. Okay, plus here since it is plus 3x into 3x square. 3 3s are 9. X square into x, x cube. Now the next term, constant 1. 3 into 1 plus 3x square. This step is okay, children? So in the next step we are changing the sign and we can add. So minus 3x raised to 4, this plus become minus, this plus also become minus. Now we can cancel 3x raised to 4 and minus 3x raised to 4 get cancelled. Now the x cube term, its coefficient is 5x cube, and here minus 9x cube. So we are subtracting the coefficients by keeping the variable same. So 5 minus 9, that is minus 4. So minus 4 x raised to 3. Okay, there is no change in the variable, we are keeping the variable as it is. And the next one, minus 7 and minus 3 minus 10. Add and give negative sign. Okay, x square. We can bring down the remaining two terms, plus 2x plus 2. Now we have the new polynomial negative 4x cube, its first term should divide with the x square, the first term in the g of x. Okay, so I am going to divide the first term, that is negative 4x cube. okay, divided by x square. Okay, as usual we can divide x cube, x into x with x square. The 2x x's and x cube, we have only one x in the numerator and negative 4. So negative 4x is the next term. So we can multiply with this negative 4x all the terms in the g of x. Okay, so negative 4 into x square. Okay, x square means coefficient is 1. So 4, okay, negative 4 x cube, x into x square. Now negative 4 into positive 3, that is negative 12 and x into x, x square. This x and this x. Okay, and for getting the next term, we should multiply this negative 4x with the constant plus 1. Okay, so negative 4 into positive 1, negative 4x. Next step, we can change the sign. Okay, and we will have minus become positive. Okay, this minus become positive, this also positive. Minus x cube and positive 4x cube get cancelled. Okay, minus 4x cube and positive 4x cube get cancelled. Now see what happens for the next term, x square term, minus 10x square. Here plus 12. So minus 10 plus 12. Okay, take the difference, 2, that is positive 2. 12 carries positive sign. So 2x square. Is it okay, children? And 2x plus 4x is 6x. Both are positive and plus 2. We have to continue the division since we have the degree of this polynomial is 2 and here also 2. What is the condition? Either our remainder will be 0 or degree definitely less than the degree of the g of x. Now it is equal. So we have to continue the division process by considering the first term, that is 2x square. Okay, 2x square divided by x square, this term x square get cancelled, positive 2. With this positive 2, we have to multiply each and every term in the g of x. So 2 into x square, 2x square, positive 2, 2 into 3, 6 plus 6x, okay, and 2 ones are 2 plus 2. We can change the sign and we can add negative, 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 negative. 2x square and positive 2x will get cancelled, 6x and negative 6x get cancelled, plus 2 minus 2 get cancelled, hence we have remainder is 0. Which means this p of x, g of x is the factor of p of x. Why? Because we have the remainder 0. Okay, that is, which implies p of g of x. Okay, g of x is a factor of p of x. Okay, this is all about this problem. So I will do one more problem from this exercise. Okay, now the third question. Here, see, this is the p of x. Okay, that is x raised to 5. In the question, this x raised to 4 term is not there. Okay, so to avoid mistakes, I just add that term by making the coefficient 0. This is not that much compulsory. If you have that much confidence, you can avoid by writing the 0 x raised to 4. Okay, and negative 4x cube plus x square plus 3x plus 1, that is given. At the same time, you see that this g of x, that is x raised to 3, now we have only 3x plus 1. Okay, minus 3x plus 1. That means here the x square term is missing. Okay, that means I am going to add that x square term. That is plus 0 x square minus 3x plus 1. That would be better. Okay, so as usual we can continue this long division process, and if you are getting the remainder 0, you can say that this g of x is a factor of p of x. Okay, children, so we can consider the first term, that is x raised to 5. Here x cube, we are dividing always with the first term in the g of x. So x raised to 5 divided by x cube, that is x square. So x square with all the terms in the g of x. So x square into x raised to 5, x cube, that is x raised to 5, and x square and 0 x square plus 0 x raised to 4, okay, and x square into minus 3x, okay, 1 3 into negative 3 x square and x become x cube. Understood? Now x square plus 1, that is x square into plus 1 is positive x square. So in the next step we can change the sign. Okay, so negative x raised to 4, x raised to 5, negative, positive, negative become positive, this positive become negative. So this term get cancelled. This is already x raised to, both are zeros, coefficient, so that term also get cancelled. So children, here we have negative 4x cube and positive 3x raised to 3. So we can add the coefficients, that is positive, negative 4, positive 3 is negative 1. If your coefficient is negative 1, we are just writing its sign, and x cube is the variable. Hope that idea is clear. And x square and negative x square, that term also get cancelled. Now we can bring down this plus 3x plus 1. Okay. So we can consider the first term of the new polynomial, that is minus x cube, okay, divided by x cube. So x cube and x cube get cancelled, but there is the coefficient of minus x cube is minus 1. Okay, so the coefficient is remaining there, so negative 1 will be there. So with that negative 1 we can multiply every term in the g of x. So negative 1 into x cube, negative x cube, and since here x square term not there, so we are not multiplying, we are not writing there because here no x square term. So I am multiplying with the x term, so minus 1 into minus 3, positive 3, and x variable, because we are multiplying with the constant, so x minus 1 into positive 1, that is minus 1. Idea is clear children, just multiplying with the negative 1, and we can change the sign as usual. So this become plus, this become minus, but this negative become positive. Okay, so negative x cube, positive x cube get cancelled, 3x and minus 3x get cancelled, but here children positive 1, after changing this negative 1 we have positive 1, so both together we will get a remainder is equal to 2. Since the remainder is not equal to 0 implies g of x is not a factor of the given polynomial p of x. Now we are solving the third problem. This is the most important problem of this exercise. Problems of this type can be expected for the board examination. Okay, see children, in this question we have given two zeros of this polynomial, and what is asked? We have to get all other zeros of this polynomial if two of its zeros are root of 5 by 3 and minus root 5 by 3. See children, this is a polynomial. The given polynomial is a fourth degree polynomial, and we know that a polynomial of degree n has n zeros. How many zeros are given in the question? 2 of them. That means we have to find out the remaining 2 more zeros. Question is clear children? Okay. So problems of this type can be solved in a different way. Okay. We have to get the factors by the zeros. This from the zeros, okay, by factor theorem. If alpha is a 0, x minus alpha is a factor. That means x minus root 5 by 3 is a factor. Okay, if minus alpha is a 0, x plus alpha is a factor. So minus root 5 by 3 is a 0, means x plus root of 5 by 3 is a factor. Okay, and children, in this type of problems you multiply these two factors. Okay, with the new polynomial obtained we can divide this polynomial. The first step is clear children? Okay, so after writing this in the form of factors, get their product. Okay, and with that number, that polynomial, we can divide the given polynomial. See children, how this product can be easily found. This is an identity, expanded form of a square minus b square, a plus b into a minus b. That is a square minus b square. In place of a, x. So x square. In place of b, root of 5 by 3 and take its square. So a square minus b square. One more step, we can simplify this one into one more step. This is equal to x square, root of 5 by 3 whole square, root and square that get cancelled. So 5 by 3 minus 5 by 3. Children, here the second term is a fraction. You can as such a divide, but it may lead some confusion. So if you are cross multiple, one more simplification step can be written. So 3x square minus 5 by whole divided by 3. And you can take 1 by 3 is a constant. So 3x square minus 5. Okay, if a constant k is coming outside, you need not divide. Okay, this polynomial along with this 1 by 3 into 3x square minus 5, this is enough. Okay, k into x square minus of alpha plus beta into x plus alpha beta, and the roots of x square minus alpha plus beta into x plus alpha beta, both are the same. So we are dividing the polynomial with 3x square minus 5 itself. Idea is clear, children? Okay. And see this one, 3x square minus 5, this is a quadratic polynomial, and the second term, x term is not there. Okay, but while we are doing the division, that point should be there. Okay, and we should write down the terms in the correct places to avoid the unnecessary mistakes. Okay, let us start the division. Okay, we are dividing this given polynomial, okay, with the product of their zeros. We got it as 3x square minus 5. Okay, so consider 3x raised to 4 the first term and divide with the first term in the divisor polynomial. 3x raised to 4 divided by 3x square. 3 get cancelled. X raised to 4 and x square. X raised to 4 minus 2, or you can cancel 2 x's from the denominator and you can cancel 2x from the numerator. Okay, so get cancelled. So 2 is remaining in the variable. So x square, we can multiply x square with the terms in the divisor polynomial. Okay, so 3x square into x square, coefficients 3 ones are 3, x square into x square, x raised to 4. Okay, now we can consider minus 5 multiply with the x square. The coefficient is of x square is 1, 1 into 5, minus 5 is minus 5 and x square. So that is minus 5x square. So that should come below this x square term. Okay, so minus 5x square. Now we can change the sign and we can add. So after changing, that first term get cancelled, and don't forget to write this term, x cube term. Okay, otherwise your answer may wrong. Okay, you can add if you want 0x cube, doesn't matter. So 6x cube. Okay, now we can solve minus 2x square plus 5x square. Subtract the coefficients, that is minus 2 plus 5, so plus 3. Okay, change the take the difference and we can keep the variable along with the difference, that is plus 3x square. Now these two terms, minus 10x minus 5. Okay, now we can continue the division by taking 6x cube minus the first term, that is 3x square. 3 in 6 2 times. Now variable we have to divide, x square and x cube. 1x will be there. Okay, so that term is 2x. So plus 2x, with this plus 2x we have to multiply in order to get the terms under this polynomial. Okay, so 2 into 3 6, x into x square x cube. Okay, now comes with minus 2 and 2, minus 5 and 2 is minus 10, and minus 10x should write in below this x term. Okay, so change the sign. This term get cancelled. You have to definitely consider 3x square should bring down, and after changing this sign, this term get cancelled and the constant term minus 5. Okay, we have to continue because now the polynomial of degree 2 here also 2. We know that degree of this polynomial is always less than this one, or this can be 0, remainder polynomial can be 0. So in order to get that one, we are continuing the division. 3x square by 3x square, that is both get cancelled. 1 plus 1, with plus 1 we can multiply. So 1 into 3x square, 3x square, and 1 into minus 5, change the sign, this get cancelled, this also get cancelled, that means 0 is the remainder. Okay, so how we got the 0, children? After writing the zeros in terms of factors, now we have the new polynomial, that is quotient polynomial, and no remainder is 0. Now listen, children, how that remaining zeros can be obtained. Obtain the remaining zeros if two of them are given. This is the method, children. That is, this quadratic polynomial x square plus 2x plus 1 is a quotient polynomial that should be factorized. And those factors are the remaining zeros of the polynomial. Understood? So we are going to factorize this quotient polynomial, that means x square plus 2x plus 1. Okay. In order to, our aim is to get the zeros. So the zeros of this polynomial are the remaining zeros. So in order to get 0, what is the rule? Equate p of x, that is this polynomial, into 0. So x square plus 2x plus 1 equal to 0. Okay, and by splitting the middle term, here the middle term is 2x should be splitted by taking the product AC. Here a is 1, the coefficient of x square, and the constant is 1. Okay, what can be the factors in order to get their sum is 2. So since 1 means 1 is the only factor for 1. So 1 can be written as, that is 2x can be written as 1x plus 1x. Okay, x into x, 1x plus 1x. Okay, so 1 into 1, 1 itself. 1 plus 1 is 2x. Okay, so that is the way I am going to split this middle term. X square plus x, then no change for the first and the third term, can be equated to 0. Now we have 4 terms, we can group them and take x from the first group and x, divide each term in the first group with the number outside. So x square by x is there, plus 1 x by x. And we can keep this x plus 1 in bracket because nothing is common between these two terms of the second group, can be equated to 0. Okay, now this plus sign separate these two terms. Okay, so we can take x plus 1 common. So after that this x is remaining and this plus, and after taking x plus 1 divided by x plus 1 is 1 equal to 0. So in order to get to the zeros, equate each factor separately into 0, which means x equal to minus 1. This also will happen if you are equating this factor into 0, x plus 1, so x is equal to minus 1. Okay, so which are the remaining zeros of this polynomial, that is the big polynomial, that they are root of 5 by 3 and minus root 5 by 3 given. The remaining zeros are 2 equal zeros because this is the identity of x plus 1 whole square. That means x plus 1 into x plus 1 equal to 0. That is what we got. So from this, the remaining zeros are minus 1, minus 1. Even if they are the equal, we have to write. Okay, so these are the remaining zeros of the given polynomial. Okay, now we are going to the fourth question. Now the fourth question, this is also very important question. Okay, children, here we have dividing a polynomial p of x cube minus 3x square plus x plus 2 with a polynomial g of x. Quotient polynomial and remainder polynomial are given. We have to find g of x. the polynomial by which we divide this polynomial in order to get the quotient as x minus 2 and remainder as minus 2x plus 4. What is the division algorithm, children? That equation p of x is equal to g of x into q of x plus r of x. From that we have, that is, what is g of x? In the theory part I explained, g of x is equal to p of x minus r of x divided by q of x. See children, p of x, g of x into q of x, okay, and if you take this minus r of x to this side, so plus r of x, that is equal to p of x. This is very important. From this we can get that the polynomial to be divided with the quotient polynomial. Okay, get their difference and divide that polynomial with the q of x is given. We are going to substitute for p of x, that is x cube minus 3x square plus x plus 2. Then minus of, we have to put bracket since r of x having two terms. Okay, and if minus sign is outside, definitely you have to keep that terms under bracket. Okay, in the bracket. So minus 2x plus 4. Why? Because here the sign is negative. That means you have to multiply each and every term with the minus sign outside. Okay, divided by q of x is given as x minus 2. So we are going to simplify by open the bracket using the distributive property. Okay, so x cube minus, up to that term no change, minus 3x square plus x plus 2, minus into minus plus 2x, minus into plus minus, okay, 4 divided by x minus 2. Now we can add the like terms, only one term in x cube, so no change, and x square also minus 3x square, but this x and 2x like terms can be added by adding the coefficient by keeping the variable as it is. So 1x and 3x, so 1 plus 2, 3x, and 2 and minus 4 minus 2 divided by x minus 2. Okay, this is the polynomial to be divided with x minus 2 in order to get g of x. Idea is clear? We just substituted this given polynomials, okay, p of x, r of x, okay, divided by q of x, and hence you can easily reach into this form. Hence we can start the division. Okay, so the new polynomial is x cube minus 3x square plus 3x minus 2 divided by x minus, simple division. Okay. So as usual we can consider the first term x cube with the first term in the divisor polynomial, that is x. So x and x cube become x square, one x cancelled. Okay. So we can write here x square. Okay, x square into x is x cube, and x square into minus 2 minus 2x square, this is already in the general form. Okay, so we have to arrange the terms according to their like terms. Okay, so change the sign. Okay, so minus become plus, so x cube and minus x cube get cancelled. Now we have to come to the next term, minus 3x square plus 2x square, minus 3 plus 2 minus 1. Okay, when we are adding the like term, there is no change for the variables, but when we are multiplying, that variables also multiplied. Okay, along with we have to multiply both the coefficients and variables, but when we are adding or subtracting like terms, we are just add or subtract the coefficients by keeping the variable the same. So you will have minus 1. So if it is 1, we are not writing the coefficient, simply sign it, which means its coefficient is minus 1. Okay, then plus 3x minus 2. We have to continue the division. So minus x square divided by x, x and x square, minus x comes in the numerator. So minus x is the next term. With minus x we can multiply minus x into x is minus x square minus x minus 2. Minus x means minus 1 is the coefficient, and minus 2 plus 2 x. Okay, and next one that is we have to add by changing the sign. So plus and minus, first term get cancelled. Okay, now the second term plus 3x minus 2x. Okay, 3 minus 2, 1. We are not writing the coefficient if it is 1. So positive a1, so x, and the next term minus 2. Okay, now we have the degree, both are the same, but either 0 or degree must be less than this divisor polynomial. Now it is equal, so that means we have to continue the division. Okay, so x with x, that is 1, so positive 1, so 1 into x, x, and 1 into minus 2, minus 2. So changing the sign, so you will be getting 0. This is the remainder. That means the new g of x. What is asked? Find g of x. So this is g of x, x square minus x plus 1. That is what is asked. So we have completed exercise 2.3. Okay, one more question, that is question number 5. That is very simple. You can easily get the examples of those questions from this exercise itself. Okay, thank you children. This is all about exercise 2.3, and also we have completed chapter 2 polynomials. Thank you children. Thank you everybody for watching and supporting my channel. Thank you all.